In this module, you will learn about permutations. In counting problems, we are often concerned with the number of unique arrangements with the available constraints. Let's see how we can count the number of possible arrangements. Here, take a frame and 3 small square tiles that can be put in the frame. Our study is, in how many ways can we arrange the tiles in the frame? Let's start with a blue tile. We then arrange the other tiles in 2 ways as shown. The other arrangements, starting with the green and yellow tiles, are as shown. We have a total of 6 arrangements. Therefore, there can be a maximum of 6 possible unique arrangements using the 3 tiles. Here, each arrangement is called a permutation. We can define a permutation as an arrangement in a definite order of a number of distinct objects taken some or all at a time. Let's analyze the pattern of permutations. For the first place of the tiles, we have a choice of 3 tiles. When the second position has to be filled, we have a choice of 2 tiles. Likewise, for the last tile, we had only 1 tile. On generalizing, we have 3 tiles for the first position, 2 for the second, and only 1 tile for the last position. Thus, we have the total number of permutations as 3 into 2 into 1. This can be generalized for any number of tiles. For n number of distinct tiles, the number of permutations is as shown. Now, we will see a theorem on permutations. Suppose we have 4 tiles to be filled in 3 places as shown. Here, repetition is not allowed. We have 4 different objects, which are 4 tiles of different colors. This implies n equals 4. To fill up the first place in the frame, we have to take 1 tile from the 4 tiles. This implies that the first place can be filled in 4p1 ways. Now, we are left with 3 tiles. To fill up the second place, we have to take 1 tile from the 3 tiles. This can be done in 3p1 ways. Similarly, the third place can be filled in 2p1 ways. By the principle of multiplication, the total number of permutations is 24. Now, we will see a theorem on permutations. The theorem states that the number of permutations of n different objects taken r at a time, where 0 is less than r is less than or equal to n, and the objects do not repeat, is n multiplied by n minus 1 multiplied by n minus 2 and so on to n minus r plus 1, which is denoted by npr. Suppose there are n objects and r spaces. These spaces need to be filled with n objects. The first place can be filled using n objects in n ways. After filling the first place, the number of objects left is n minus 1. Now, the second place can be filled with n minus 1 objects in n minus 1 ways. Similarly, the third place can be filled in n minus 2 ways. Continuing the same process, the rth place can be filled in n minus r plus 1 ways. According to the fundamental principle of multiplication, the total number of permutations is as shown. This expression is denoted by npr. Here, n is a natural number. To clarify this further, Let's take up again the example of tiles that we saw earlier. Suppose if we have 4 tiles to be filled in 3 places as shown. Here, repetition is not allowed. We have 4 different objects, which are 4 tiles of different colors. This implies n equals 4. There are 3 places in the frame. This implies that we take 3 tiles at a time to fill the frame. Therefore, R is equal to 3. Therefore, the number of arrangements can be done in 4p3 ways. This result is similar to the one we saw earlier. Till now, we have come across situations where we multiplied natural numbers as shown here. We will use a convenient representation to depict such products. The representation is called a factorial. For example, the multiplication of the numbers that we saw is represented as shown and is read as 3 factorial. As a general representation, if n is a natural number, then n factorial is written as shown. For n is equal to 4, we have this representation. Now, we will see an alternate representation of NPR. We know the formula for NPR. We divide and multiply by n minus r factorial. Then, we expand the n minus r factorial in the numerator. Therefore, the numerator becomes n factorial. This representation is used for computing NPR.